So in this video, I'm going to talk about the bottom part of the solubility rule. It's like what happens when you have double displacement. So double displacement take place only when you have both of the condition met. And when you have double displacement take place, you're going to balance the equation. So one of the two conditions that you tell that double displacement take place is number one, both reactants must be aqueous, because if they're aqueous, they can be separated to switch partners. And either gas or PPT or water liquid is produced. These two must be met at the same time for you to say double displacement take place, then you can balance the equation. And double displacement would not take place, okay, is when either of these conditions is met. So when you have when you have no reaction, don't even balance. And the two conditions are one or both reactants are not aqueous. Because one of them is not aqueous, that means they stay in the water as like a whole thing. They will not separate it. They will not be able to form charges. They will not be able to switch partners. Or if you after you switch them, no gas, no PPT, no water is produced. That means they just sit in the beaker. There will be no reaction take place. Now here I give you a very nice paper. Is you gotta follow the step. Is you gotta first identify the double displacement, meaning compound, and then make sure that the both reactants are AQ by using the charge on the top, and then you underline them and you form the charges. Okay, you underline them, you form the charges. You go back to crossover, or you can find the charges from the periodic table, or you can find the poly sheet, and then you want to draw the rainbow. Okay, draw a rainbow, and then you put the positive charge and negative charge in the clouds. So for example, I start with the red one, so I put these two into the cloud, positive first, negative next, and then I have the second cloud. This second cloud, the green one, but must be positive first, negative next, so will be this order. And then you cross over back to form the compound, and then you use the chart to check the solubility, whether they precipitate or aqueous or not. So if they number A, if they have to form the gas or PPT or water is produced, you can have the reaction take place, then you can balance the equation. So now here I have 4 situations. So this situation is same thing as here, is like I met both the conditions. So these are the reason part. Okay, so why does the reaction take place? Why do I need to balance the equation? It's because both reactants are aqueous, and one of the thing which is the Ag2SO4 is PPT is produced. So then the reaction take place. I'm going to put a check mark and balance them. Now this one I do switch partner, but why as no reaction? Why I don't continue to balance them? Is because no gas, no PPT, no water is produced. You see that they're all aqueous. And then these two, why there's no reaction? Because both of the reactants are not aqueous for here, a solid, or one of the reactant, AgCl, is not aqueous. So no matter what, if you have not aqueous for all of the cases, you don't even write the rainbow, you don't even split them, because they're solid. That means they stay in the water, they will not separate it. So you should stop, you say no reaction, because of these two reasons. Okay. Now I'm going to do number 1, 2, 3. Okay. And first of all, you need to identify them. They are double displacement because they are solid and solid. They are compound and compound. And then you're going to look up KOH, a hydroxide. You're going to check the state. Hydroxide is soluble except with 1. Hydroxide are insoluble except with 1. So that means it is soluble because K is group 1. So it's going to be AQ. Okay. Now HCl, chloride. So chlorides are soluble, no exception. So chlorides are soluble. So AQ. Now if they are both AQ, I can separate them. If they're both AQ, I can separate them. Okay. So I'm going to start with the middle, the inside. Okay. I'm going to underline them. And the hydroxide, you can either cross over back to find the charge, or you can look at the poly sheet. The charge for OH is OH minus, and here is H plus, because Cl is minus, then H must be plus. And then I'm going to draw the rainbow. And then the second thing is they underline the outside. So underline the K and underline the Cl. So K plus and Cl minus. Again, you can either look at the periodic table, or you can cross over to find a charge, and then draw the rainbow. I'm going to bring the red to the cloud first, so K plus, Cl minus on the cloud. And then now they cross over back to form the compound. So I write down the coefficient line. They cross over to get KCl. And then KCl, if you look up the chloride is soluble, no exception. So this is AQ. Okay, and then the green thing. Okay, so the green thing is I'm going to bring this here, but you have to be careful, positive first, negative next. So I'm going to put H plus and OH minus. Okay, so this is actually H2O, and H2O in double displacement will be liquid. Okay, double displacement will be liquid, combustion will be gas. So now here you can tell that actually reaction take place. Why? Because number one, both reactants are aqueous. Number two, water liquid is produced. So I'm going to use the flat pen to write down the two reasons. The reason you can actually copy from here, like get the idea. So number one, both reactants are aqueous. Okay. So number two, H2O liquid is produced. Okay. So based on these two, we say that, okay, reaction took place. I'm going to put a check mark on it, and then I'm going to balance it. I'm not going to go for the balancing. Okay, it's going to be 1, 1, 1, 1. Okay, so number one is done. So number two, I assume that you guys are okay with the aqueous and the solubility. So I will just tell you that this one is AQ. This is also AQ. So by both AQ, I can draw the rainbow. So I underline these two. So PO4 is 3 minus. You can actually look at the poly sheet, or you can actually cross over. And then Na will be plus. So I'm trying to rainbow. And then the K will be plus, and then Cl will be minus. And then I'm going to draw the rainbow. Okay, so the first rainbow, I'm going to bring the K plus and then Cl minus on here. And then I'm going to cross over back to get KCl, and if I check the solubility is aqueous. And then the second one is, again, would be positive first, Na plus, and then parenthesis PO4, 3, 1 minus. We cross over back, and I got Na3PO4. And this one, you catch solubility charge, you can tell that this is aqueous. Okay. Now this situation, reaction would not take place, because even though the two reactants are aqueous, but if you look it up, there's no water, no gas, no PPT is formed. So actually the reaction would not take place. And the reason is that no gas, no PPT, no water liquid is produced. Okay, so no gas, no PPT, no water produced. So with no reaction, we don't even balance the equation. Just leave it like that. And then number three, zinc hydroxide. I believe this is solid. And then the K2S is AQ. Now in this case, I don't even want to draw the rainbow, because in order for you to draw the rainbow, both must be AQ. This is solid, that means they stay in the water as a whole, so they can't be separated. So it will be just no reaction. I don't even draw the rainbow. You only draw the rainbow when you have both AQ. So here would be stop reaction, no reaction. And then the reason you're gonna write, okay, one reactant, you're gonna tell me which one. Okay, one reactant, zinc hydroxide, solid, is not aqueous. Okay, so if you say one reactant, you have to tell me which one, particularly. If this is both reactant, you can just say both reactants are not aqueous. So the step here, the reason here, I follow from the worksheet.